Hello, and welcome to Choose the Right Google Cloud Database for your workload. My name is Chris Taylor, and I'm the engineering fellow responsible for Google Cloud's databases. Today, I'll be giving you a quick overview of what databases Google Cloud has to offer, and a little more detail about how to pick the right one based on the needs of your applications. At Google Cloud, we offer industry-leading databases for any size organization. On the left side of this slide, you'll see our offerings for third-party database engines. Memory Store is a fully managed service for Redis and Memcache. Cloud SQL is our fully managed service for MySQL, Postgres, and SQL Server. Bare Metal Solution offers state-of-the-art certified infrastructure and allows you to bring Oracle workloads to Google Cloud with less than 2 milliseconds of latency to all Google Cloud services. On the right side, you'll see Google's database engines. AlloyDB, which brings the best of Google to Postgres. Spanner, the no-compromise database that gives you the best of relational and non-relational databases. Bigtable, the pioneer of NoSQL databases that delivers low latency and high throughput for enterprise workloads. And Firestore, serverless document database for agile development of web and mobile applications. Today, we're going to learn more about all of these. I want to start with Postgres, because if you're like the customers I usually talk to, you too are probably starting with Postgres by default. You use it, you like it, you plan to use more of it. We like it too. We've invested heavily in 3 great options to make sure almost any need you have is covered, from fully open Cloud SQL to AlloyDB, which is open source Postgres customized for enterprise performance and reliability, and Spanner with a Postgres interface to accommodate the biggest and most demanding workloads. Because we have several good options, it's worth deep diving to understand them better. As I do, keep in mind that for typical customers with many workloads, this isn't an either-or choice. We find that many customers use 2 of these or even all 3, depending on their use cases. I want to start by talking about AlloyDB, which we believe for most enterprises is a great default choice. It's fully Postgres compatible, but gives you critical capabilities including a 4.9 SLA, great read scale out, automatic smarts to reduce your management burden, and really, really great performance. I'll touch on a few of these in a bit more depth, since I think they're really very cool. As you saw on the last slide, AlloyDB offers 4 times the transaction performance of open source Postgres. In AlloyDB, we've really tuned the write path of Postgres and offloaded block maintenance to a special storage engine. That storage engine offloads the database servers, leaving more room for your workload. The AlloyDB storage engine also allows you to scale read replicas with very low lag. So that's writes. We've also really innovated on the read side, where we have 2 major techniques that make many common workloads fast. First, we have an automatically attached SSD cache, which we dub the ultra-fast cache. The ultra-fast cache does what it says on the label. It significantly improves throughput and reduces latency when workloads are too big for RAM. Even more interestingly, we've just developed the AlloyDB columnar engine, which you can enable for more analytical workloads. It's quite common for customers to enable columnar engine for read replicas. The columnar engine automatically maintains a projection of your data in a columnar format. If you've used a data warehouse in the past, you're probably aware that columnar representations are one of the most important techniques for accelerating analytical queries. With AlloyDB, you can often get that kind of performance without adding a warehouse or configuring ETL. And because the AlloyDB columnar engine is automatically maintained in database, you always get a consistent correct answer with no lag. We've seen the columnar engine provide up to 100 times faster analytical queries than standard Postgres. That level of performance enables customers to escape legacy architectures that are much more complex and much more expensive. Beyond performance, AlloyDB eliminates the drudgery of maintaining a Postgres database. One such operation is vacuuming, where space from deleted tuples must be reclaimed through a manual process. AlloyDB does this behind the scenes using advanced self-tuning machine learning algorithms. Auto vacuum is just one taste. There's even more. So even for workloads that maybe don't push the performance envelope, AlloyDB still helps the database stay out of your way and helps your application run more smoothly. Last year at Next, we announced AlloyDB AI, an integrated set of capabilities built into AlloyDB to help developers build performant and scalable GenAI applications using their operational data. AlloyDB AI helps developers more easily and efficiently combine the power of LLMs with their real-time operational data, providing built-in end-to-end support for vector embeddings. This includes high-performance vector search, easy embeddings generation, including support for third-party models from vendors like OpenAI, and integration with the GenAI ecosystem. We recently released a PG vector compatible extension for vector indexing based on Google's internal vector search technology, which delivers up to 4 times faster vector queries, up to 8 times faster index build times, 10 times higher write throughput, and typically a 3 to 4 times smaller memory footprint than the HNSW index in standard Postgres. We think AlloDB is amazing, and it's a great fit for many Postgres workloads, especially those coming from legacy databases. But we also know many of you are happily running open source Postgres today and want higher availability and lower operational toil. Cloud SQL is our fully managed relational database service for MySQL, Postgres, and SQL Server, and is used by more than 95% of Google Cloud's top 100 customers. It provides simple and high-quality management of the databases and database versions you already use. What we've found working with many customers over many years is that when you have one eye on your application and the other eye on your database, there's only so far you can go. With Cloud SQL, you can go further. We think we've found a happy balance where you get the exact open source versions you've qualified in your application, but also benefit from the wisdom we've accumulated about how to run it optimally and with no fuss. We recently introduced Cloud SQL Enterprise Plus for MySQL and Postgres that provides higher availability and enhanced performance without compromising at all on open source compatibility. We designed Enterprise Plus to give you more choice and flexibility as more demanding workloads move to the cloud. For example, Cloud SQL Enterprise Plus delivers up to 3 times higher read throughput and up to 2 times improvement in write latency compared to the base Enterprise edition. It also features a 4 nines availability SLA and near zero downtime for planned maintenance operations. Enterprise Plus really lets you have your cake and eat it too, where you get enhanced performance and availability without losing Cloud SQL's meticulous, down-to-the-minor version compatibility with open source. And finally, rounding out our collection of solutions for Postgres, we have the Postgres interface to Spanner. Here, our goal is to offer you uncompromising scale and reliability in a package that fits into your existing developer workflows and can leverage skills you already have. What we typically see with customers is that once a Postgres database starts approaching 10 terabytes, quite a few aspects of operations get more challenging. While we support many customers at higher sizes very successfully on Cloud SQL and AlloDB, this is where Spanner can start to look quite appealing. Spanner is also our best option for truly mission-critical applications that need the highest availability. At Google, we put Spanner and its 5 nines availability SLA in the critical path of Workspace, Web Search, YouTube, even Google Cloud's own control planes. Now that scale and reliability isn't completely free. You won't have the full surface compatibility you get from AlloDB or Cloud SQL, and you will have to think about sharding keys. But if you really need to scale Postgres, Spanner can do it. And if in the future you need to migrate out, with Spanner's Postgres dialect, you'll be able to take your code with you. To see these trade-offs in action, let's look at a customer story. I mentioned earlier in the talk that many of our customers use more than one or even all 3 of our Postgres solutions. I wanted to walk through one of my favorite examples, which shows how Google Cloud can support you through all stages of your Postgres journey. Character.ai uses an advanced neural language model to allow users to have lifelike conversations with fictional and historical characters. When they were just getting started, they chose Cloud SQL for Postgres, and were able to get a novel business off the ground quickly using proven technology they already knew. But as their business grew, they needed another answer to scale. With AlloDB, they were able to quickly take their same stack and scale it to much higher load, 150% increase in QPS and 20x read scaling with AlloDB read pools. Even that, though, wasn't quite enough for their main chat experience, so they refactored just that high-volume part of their application into a Golang microservice backed by Spanner. Spanner enabled Character.ai to scale to terabytes of data daily, with no limits in sight. I really love this story because it shows how Google's depth and breadth in Postgres can fundamentally change what is possible for our customers. So now we've covered the main relational options: AlloDB, Cloud SQL, and Spanner. How do you get there from where you are today? We see most customers picking one of 3 paths, and again, a typical customer has quite a few databases and will often take a different path for each. The 3 paths are migration, modernization, and transformation. No matter what your goals are for your application, we think we have a path that can help you achieve them. Now let me walk through each in slightly more detail. For super simple migrations, we have a complete range of like-for-like managed options and database migration service to help you get there. DMS also makes it really easy to try a low-stakes POC of Google Cloud's unique offerings like AlloyDB and Cloud SQL Enterprise Plus, so you can see the differentiated performance for yourself. For challenging Oracle workloads, bare metal solution can get you bare metal hardware running Oracle database within 2 milliseconds of Google Cloud regions, allowing you to get Oracle applications up and running on Google Cloud without major application changes. So that's migration. Let's talk about modernization. It's an open secret that many companies want to refresh their database estate and get to open platforms and reduce their dependence on legacy systems. At Google Cloud, we have the ingredients you need. First, we deliver an enterprise-class database runtime with AlloyDB. This high-end Postgres offering can meet the requirements of the most demanding workloads. And with AlloyDB Omni, you can modernize in place, no matter where you need to run your databases, on-prem or other clouds. And we've dramatically simplified the migration process. If you've looked into moving legacy applications in the past and shied away from the porting cost, it may be worth having another look. So let's look at the assistance we have to help you with migrations. We have the Database Migration Assessment tool, which can help you find the best modernization candidates and scope the effort to move them. Second, our Database Migration Service provides schema and data migration support, as well as Gemini-powered code conversion for things like stored procedures, which in our experience significantly outperforms more heuristic-based methods you may have seen in the past. Third, we have a Database Migration Center of Excellence, where you can get high-touch support to make your migration successful. And finally, we have attractive financial incentives to help offset some of your migration costs. We've been working with customers on these kinds of moves for several years now, and have really learned a lot that can help you be successful too. Let's look at one example. Renault moved over 70 in-house applications to Google Cloud over a 2-year period. And you'll notice that's even before we had Gemini-powered code conversion, and landed on Cloud SQL for Postgres. They found the move improved stability and latency and reduced toil compared to their legacy database, as well as significantly reducing their costs. If you leave with nothing else, it has never been easier to get off legacy databases, and we can help. Our final path to database success is transformation, taking advantage of the opportunity not just to change database platforms, but to rethink your application architecture for simplicity, scale, and availability. Customers who take this path pay higher upfront development costs. After all, the point of transformation is to have a different and better application at the end. But when you undertake it, you can end up with a very clean, cost-effective, and agile application. I want to show an example of Spanner-enabled transformation at a major retailer. So this is their pre-Spanner architecture. These systems were in their buy path, and especially on peak shopping days, sustained quite significant load. The need to be ready for these peaks pushed a lot of complexity into their system, whether it was splitting key data into different databases, which they had to maintain, or provisioning them for peaks, which was expensive. Rather than migrate or modernize these databases as they were, this customer decided to consolidate all of these into Spanner in a bid to radically simplify their systems. At a glance, you can see what a difference this transformation made. By recombining their many databases into one larger Spanner database, they no longer need to manually stitch data from several systems together in their application, or manage consistency across multiple databases. Also, their engineering team has a lot less complexity to manage day to day, and is able to really trust that their database will be online and available, even when traffic surges during events like Black Friday or Cyber Monday. We sometimes talk about scale one database at a time, but the real opportunity unlocked by Spanner's scale is the ability to reconsolidate data that belongs together and fundamentally simplify your applications. So that wraps up our overview of relational databases and relational database migrations with Google Cloud. From there, Spanner makes an excellent bridge to looking at Google Cloud's options for scale-out and non-relational databases. Whether you're handling huge volumes of writes from logs or click streams, trying to rapidly launch a new mobile application, or just build data-driven applications without worrying about scale, we have you covered. So let's start with some definitions. At Google, we think about scaling in 2 dimensions. Scaling up is when you increase capacity by replacing a small server with a larger one. With modern servers and VM architectures, this works really well for many applications. It's a great plan, to a point. Scale out is our term for achieving scale by adding servers. In Google's scale-out databases, you can scale by going from 1 server to 2, or from 100 servers to thousands or tens of thousands. This radical scalability, which is critical for big workloads, is fundamentally enabled by key sharding, or just sharding. By splitting up the rows of your tables across servers, you split up your application's workload and enable it to scale linearly as servers are added. Google takes sharding and scale-out to the next level with completely disaggregated storage and compute. Google's scale-out databases store the physical data in a huge cluster file system we call Colossus, which provides very high I/O bandwidth and excellent latency. Our database servers still shard, but a database server can own rows without having to physically store all of their data. Row ownership just means processing the reads and writes. This is really a game-changing upgrade on standard dynamic sharding, where servers have to directly store data. At Google, when we move rows between servers, we don't move data. Instead, we move a small amount of metadata. This can happen very fast, and because it happens fast, we can do a lot of it. And in practice, that means you can run our systems much leaner, and even scale up or down intraday to save money. And if you're caught by a sudden change in traffic patterns, our database can react before you even notice. I hope I've whetted your appetite a bit for Google's scale-out databases. It's truly one of Google's deepest veins of technology innovation. And this year, we're celebrating the 20-year anniversary of Bigtable, the Google database that really kicked off the NoSQL movement, inspiring followers like HBase and Cassandra. In those 20 years, Google has built its entire business around the scale and capabilities of its scale-out databases. During that time, we've learned a lot about the ins and outs of how to make this kind of system really hum. I continue to be staggered by the number of critical details that go into making scale-out really smooth, predictable, and application-friendly. In the final segment of this talk, I'll cover our three major scale-out systems: Bigtable, Firestore, and Spanner, and how you can best take advantage of their capabilities. I'll start the tour with Bigtable, the eventually consistent key-value store that kicked off NoSQL. 20 years on, Bigtable continues to be critical to Google's own success. It has more than 10 exabytes of data under management and processes more than 7 billion requests per second at peak. Bigtable is a key-value store with schemaless column families. Bigtable's sweet spot is workloads that need to ingest a lot of data for later analysis, whether that's clickstream, time series, log analytics, or user activity data. If you're doing more writes per second than reads, Bigtable offers truly differentiated price performance. Bigtable replication is eventually consistent, and that means you can do low latency writes at any replica. And if your application is comfortable with the semantics, there is no better way to get ultra low latency writes and high availability in a global application. Next, I want to talk about Firestore, Google's fully serverless document database. This database was designed to work seamlessly with Firebase so that you can very quickly build and deploy a quality mobile application. To really facilitate rapid progress on greenfield applications, we have a flexible document data model and mobile and web development SDKs that enable you to build both online and offline experiences for your customers. Because Firestore is truly serverless and has a generous free tier, you can build small applications at zero or very low cost. In fact, I have a small Firestore application I wrote for my family that costs me about $1 a month. And I'm not alone. More than 500,000 monthly active developers use Firestore. Our final database in the scale-out non-relational category is Spanner. We of course saw Spanner earlier when we were talking about relational databases, but Spanner is excellent in traditional non-relational use cases as well. We've been working on Spanner at Google for 15 years. Our goal was to combine the scale, latency, and cost profile needed to serve key-value workloads with the higher-level capabilities and developer productivity of a relational database. Today, Spanner processes over 4 billion requests per second at peak and has more than 15 exabytes of data under management. With Spanner, you get great cost and performance on simple workloads, even compared to specialized non-relational systems, while you also get a big tool bag of capabilities you can draw on as you add requirements over time. Earlier, we saw an e-commerce customer consolidating multiple relational databases into Spanner. Spanner's customers also do the same across relational and non-relational databases. If your application is using a relational database for semantics and a non-relational database for scale, Spanner can give you the best of both worlds with much less application plumbing. Well, there's far more I could say about databases and database selection than can really fit into 20 minutes. As we often remark, customers choose databases for lots of reasons, and it's a challenge to give crisp guidance that will be right for every case. But I hope you have a better sense of what Google Cloud has to offer, and perhaps how your workloads could map onto it, whether that's Cloud SQL, AlloyDB, or something else. Thank you for taking the time to join me today. I hope you've learned a lot about how our databases work, and you'll consider using one of them in the future. Thanks again.